Public lecture video by Zach Braun. We will be covering the lecture by Dr. John D. Pills about illustrated special relativity through its paradoxes. Dr. John D. Pills is from the University of California at Riverside. The paradox is if the bug is killed by impalement by the rivet by observing two different frames of reference. The plates and rivet shank are separated both by length d. After separation, the rivet travels from the left going into the plates at a speed of 0.8 times c, which is the speed of light, where a bug waits on the right-hand plate. This picture shows the at-rest distance d between the sides of the parallel plates. This picture shows the two frames of reference, one from the plate and one from the rivet. Now we see that on one frame the rivet is in motion, and the other frame the plate is in motion. This picture shows that the rivet is in motion while the plate is in motion in the other frame. You can see this by 0.6 d on the rivet on the top frame and 0.6 d on the bottom on the plate. Now here's where the paradox occurs. At one moment in the plate, the bug is touched by the rivet, and in the top one where the frame references the rivet, the bug remains safe and untouched. The paradox really comes into effect when one bug is killed in one frame of reference and the bug isn't killed in the other reference. Because the bug is killed in the plate's frame of reference and not yet in the rivet's frame of reference, this means that if the rivet shank were to stop expanding, then that would imply that the future affects the present. This means that the rivet tip would know about the collision before the collision signal arrives. Let's now go back and look at each frame of reference. In the plate's frame of reference, the non-moving plates see the incoming rivet with a shank that is only 0.6 times its original length. Hence, at the moment of collision t, the rivet will be too short to kill the bug. In the rivet's frame of reference, the non-moving rivet sees the moving plates with a space between them that is only 0.6 times its original space. This means that at the moment of collision t, the bug will be killed by the too long rivet shank. The result is that yes, the bug is killed by the rivet. In the rivet's frame of reference after the moment of collision t, and in the plate's frame of reference before the moment of collision t. This implies that the rivet knew about the collision before it occurred, therefore implying the future affects the present. Dr. John D. Pillis said that, in fact, special relativity requires that after collision the rivet shank length increases beyond its at-rest length d. He says this is needed in order to clearly identify that Einstein's 1905 false light postulate is unfalsifiable. Anytime some experimental argument shows that the speed of light is variable, Einsteinians immediately change some length so that the speed of light can remain constant. When the observer starts moving toward the source of the light, and as a result, the wave crests start hitting more frequently. This does not mean that the speed of waves relative to him has increased. No, rather, the wavelength has decreased so that the speed of waves relative to the observer can remain constant. Divine Einstein, yes, we all believe in relativity. That was a direct quote from Dr. John D. Pillis, and it explains the bug rivet paradox. Thank you for watching my overview of Dr. John D. Pills' lecture on the illustrated special relativity through its paradoxes. I covered just a section on the bug rivet paradox. Thank you again for watching.